Okay, this is part 2, looking at the power of compounding. And the first video we talked about simple interest, compound interest, and identified how we kind of come up with those ideas, where they stem from. Now we're going to do some calculations again. Just as a reminder, here is the formula we're going to be using for compound interest. And I recommend you have a scientific or graphing calculator ready as we go through some of these calculations. So we are going to use the appropriate compound interest formula to compute the balance in each account after the stated period of time. So the first one, we have $5,000 is invested. So that tells us that our principal is $5,000 for 10 years. So that tells us that the number of years, so in our formula, capital Y is not 1,000, it's 10. Sorry about that. With an APR of 2%, well, that's 0.02, so it always needs to be a decimal, and quarterly compounding. So there are 4 quarters in a year, so that means our N is equal to 4. So the future value, or the amount compounded after 10 years, is going to be equal to our principal times our rate, which is 1 plus the APR over the number of times compounded raised to the power of number of times compounded times years. Okay, and this is where having a calculator will be key, because if you try and do each one of these steps individually, it will be difficult. But if you have a scientific calculator or a graphing calculator, you can do it all at once. But when you multiply all of this out, you should get about $6,103.97. So please be sure that you're able to get that in a calculator. If you are unable to get that, let me know and we can work through that. But that's the amount you would have after 10 years with a 2% interest compounding quarterly. So you can see you made just over $1,100 in interest over 10 years. Okay, next we have $30,000 is to be invested. So again, our principal here is $30,000 for 15 years. So Y is 15 years, APR 4.5%. So again, change that to a decimal every time, compounded daily. So this time we have 365 days. So our number of times compounding is 365. So the amount is going to be the principal, $30,000, times 1 plus 0.045 over 365 raised to the 365 times 15 power. So as we compound more, so this time we're compounding 365 days, the more we compound, the more times we're getting that interest and earning more money. So we're compounding daily at 365, and if we type this in here, I get about $58,918 and then 54 pennies, so 54 cents. So that's how much you'd have after 15 years with an initial investment of $30,000, compounding daily at 4.5% APR. So please make sure again that you're able to get those numbers in the calculator. If not, contact me so we can work that out. If you're using a cell phone, you're going to have all sorts of rounding stuff if you're using the basic calculator on there. So recommend, again, a scientific calculator. I'm trying to do all of the calculations at one shot rather than doing the individual parts, because you have to round. Okay, now this next one, we're going to be looking at planning ahead. So we want to know how much you must deposit today. So we want to know the principal. So in this case, we don't know the principal. And so we want to know how much to deposit in the accounts in order to have $25,000. So that means the amount we eventually want to have is $25,000 8 years from now, or 8 years down the road, for a down payment on your house. And we'll assume that no other deposits are made, so you're not, you're not depositing money every year or every once in a while or anything like that. You just, how much do you put in and then leave there for 8 years to accrue or have $25,000 in the end. So we're still going to use the same formula, but this time we have the amount is $25,000 equals the principal, which we do not know, times 1 plus the APR of 0.04. Daily compounding again over 365 raised to the 365 times 8 years. And we need to solve this equation here for P. Well, if you think about it, P is being multiplied by this big old honking thing right here. And what we do is we just divide by that big thing. So divide by 1 plus 0.04 over 365 raised to the 365 times 8 power. And divide by that over here as well. Just using some simple algebra. So what happens is these things cancel out over here, and we get principal equals this thing right here, 25,000 divided by 1 plus 0.04 over 365 raised to the 365 times 8 power. So again, this becomes calculator work. Make sure that you're able to type this into a calculator and that you're able to get the value of $18,154.04. So that's what you should get when you type in that big 25,000 over 1 plus 0.04 over 365 to the 365 times 8 power. Again, a scientific calculator would work very well. The one that I use is a Casio FX-300 ES Plus, and it works very well. There are many others out there, but that one, I picked it up at Walmart for like $9, and it does these things very, very well. So, again, if you can't get those, please contact me so we can help you out on that. Okay, so now we're going to be looking at what happens when we compound continuously. Just checking my time there. We're still doing good. Okay, so it's compounding continuously. So as the number of times we compound grows, we're going to get some more interest, but eventually there becomes a peak. So when we look at compounding when n equals 1, so that's annually. Semi-annually is 2. Quarterly is 4. You can get monthly, which is 12. You can get daily, which is 365. You can go down to hourly, every minute, every second. And compounding continuously is always compounding. At any fraction of a second that you can imagine, this thing is compounding. And the formula is this. It's the amount equals the principal times this number E raised to the APR times Y power. And the question is where does this value E come from, which is 2.71828, and it is in your calculator, so use the number in your calculator. But remember, in our when we're compounding compounding interest, there's something that looks like this structure, and I'm gonna pull out the APR, but you have something like this in this form. And what happens is as the number of times you compound, or as n gets really big, so we say as n approaches infinity is the way we would mathematically say that, then this concept right here, 1 plus 1 over n raised to the nth power, which is kind of an underlying structure that we have in the compound interest, okay, that approaches this number E, which is called Euler's number. Not something you necessarily have to remember that it's called Euler's number, but and if you're wondering, his name is spelled like this, Euler. Okay, it approaches E, which is approximately that number right there, 2.71828. So that's where we get this formula for compounding interest continuously. Okay. So now let's look at what happens here when we're compounding continuously, and we want to determine what happens when we're compounding continuously after 1 year, 5 years, and 20 years. So we have $5,000 deposited, so our principal is $5,000. Our APR is 4.5%, so the APR is going to be 0.045. So after 1 year, so this is where the year equals 1, we get the amount equals 5,000. Okay, and then times E, and you can use that in your calculator. It's in there, but it's approximately 2.71. Raised to the APR times the number of years power. So when you do that for 1 year, you should get about $5,230.14. Now, after 5 years, the only thing that changes here is we do 5,000 times e to the 0.045 times 5 power. So after 5 years, this thing is going to be worth about $6,261.61. And then after 20 years, again, the only thing we're changing from year to year is that exponent is being multiplied by 1, 5, and 20. So after 20 years, the value of this thing is $12,298.02. Okay, so that's after 1 year, after 5 years, and after 20 years. Now it also asks us to find what's called the APY, the annual percentage yield. That will be just a little bit later in this lesson. Okay. Let's see, I think we're probably getting close here. So let's go ahead and I'll pause our video here, and we will pick this up in a part 3.